Let's dive into the internal assembly of a clutch. The clutch basket is the outermost part of the clutch assembly. As we saw earlier, it is connected to the crankshaft and rotates whenever the engine is running. However, it is not connected to the transmission, so it does not transfer power straight to the gearbox. Another major component of the clutch, known as the clutch inner hub, is assembled inside the clutch basket. It is connected to the transmission system and therefore spins with the gears in the gearbox. This means we have the inner hub that spins with the transmission and the clutch basket that spins with the engine power. With this setup, if we insert a connector between these two components, the engine power can be transferred to the gearbox. Removing the connector will disconnect the power. While inserting and removing the connector, we have assumed both the clutch basket and the inner hub are stationary, but in reality, they typically spin at different RPMs. Inserting a solid connector between two non-synchronized spinning components is nearly impossible, so engineers came up with a brilliant solution and divided the connector into two separate components. One of them engages with the clutch basket and rotates with it, but it does not interfere with the inner hub. It can also slide sideways due to the design of the basket and tabs. Another connector is designed to engage with the inner hub. Now let's assume the engine is running, which causes the clutch basket to spin along with the connector engaged to it. Now let's slide the connectors toward each other until they're in contact, which develops friction. With sufficient contact pressure, the friction will start rotating the other connector, which rotates the inner hub. To disconnect the power, we can simply release the pressure and the power is disconnected again. The two thick connectors we used here are just for demonstration purposes. In practice, multiple thin plates called friction plates and metal plates are used in order to increase the contact surface area. They work just like the two connectors we observed earlier. All the plates are held together with the help of a pressure plate. A set of springs provides the force required to develop the pressure between them. So how is the pressure on the plates released? To understand this, we need to understand the internal working mechanism of a clutch. Let's observe the cutaway view of the assembly for better understanding. A set of springs sit between the pressure plate and the inner hub and is held at the appropriate tension using clutch spring nuts. This develops friction between the plates and the power is transferred. In order to release the pressure plate needs to be pushed outward, as shown. The force required to push the pressure plate